Now let's get some practice with exponential and logarithmic functions. We're going to evaluate a bunch of logs just to get used to doing that, and then we'll get more comfortable with them as we go. And then we're going to solve for x and a bunch of exponential functions just to get us comfortable with both sides. So let's think first about this one, log base 3 of 27. So I'm asking myself what power of my base is equal to this number here. So what power of 3 is equal to 27? Well, 3 to the first is 3, 3 squared is 9. If I multiply that by 3 again, which would be 3 to the third, I get 27. So I know that 3 to the third is equal to 27. So that means that the answer to my question is 3. So log base 3 of 27 is equal to 3. If we think about this one, if we think about 9, powers of 9, 9 to the first is 9, 9 squared is 81. So this is 9 squared. So the answer to our question is that 2 is the power of 9 that gives us 81. So that's our answer. Let's look at this third one, log base 2 of 16. So if we think about powers of 2, 2 to the first is 2, 2 squared is 4, 2 cubed is 8, 2 to the fourth, if I double that again, would be 16. So our answer is 4. That's the power of 2 that gives us 16. Then what about log base 11 of 121? Well, 11 to the first is 11. 11 squared is 121. So our answer would be 2. Now let's look at this one. Let's think about powers of 9. 9 to the first is 9. 9 squared is 81. So we skipped over 27. That means that 27 isn't one of our normal integer powers of 9. We need to think about it a little bit differently. So for a second, I'm just going to call this x. I'm going to say that the power of 9 that's equal to 27 is x. We still need to figure it out, but I'm going to give it a name. Because I want to write it back in this form, the exponential form. We know that 9 to whatever that power is equal to 27. Now, is there any connection between 9 and 27? Ideally, some sort of exponent. Well, if I think about 9, that's 3 squared, and 27 is 3 cubed. So let's rewrite each of those things as its power of 3. So 9 is 3 squared, so I've replaced it. And then 27 is 3 cubed, so I've replaced that. But if I take 3 squared to the x power, I'm taking 3 times 3, but x times. I'm taking x copies of that. So I'll end up with 2 times x copies of 3, because there are 2 3's in each of these. So there's actually an exponent rule that tells us that 3 squared to the x power is 3 to the 2 times x power. And that's equal to 3 to the third. Now if I take log base 3 of both of those, then what I see is I'm trying to think what power of 3 gives me 3 raised to the 2x power. Well, that's going to be 2x, right? Because that I already know, because of the way this is given, that I'm taking the 2x power of 3. Here, I'm trying to think what power of 3 gives me 3 to the third power. Well, we don't have to think too hard about that. It's 3. It's the only way we're going to get 3 to the third power is by taking the third power. So we end up that these two exponents are the same, so we can divide by 2 on both sides. We get that x is equal to 3 halves. So that's the answer to this logarithm here. So now let's go through and do some exponential practice. So let's think, what about if I have 7 to the x power equals 49? Well, I can either think about it here in this form, or I can switch it to a log. It would be log base 7, it's equal to 49, and x is the power that I'm looking for. But if we think about it, 7 squared is what gives us 49. So x is equal to 2. So this one is kind of interchangeable, whether we look at it this way and think it's easier or that way. Either one will work. We can kind of flip-flop back and forth whenever we want. Now let's look at this one. We're taking 16 being raised to a power and we're getting 4. So usually when we take powers of something, especially integer powers, we're getting something bigger, not something smaller. So we need to think a little bit about this one, and it's probably going to come out to be something similar to this. And if I think about a base that both of them share, 16 is 4 squared. So I'm raising that to the x power, and 4 is just 4 to the first power. So this tells me that 4 to the 2x power is the same as 4 to the first power. So just like I did up here, I can take log base 4 of both sides. So if I think, what power of 4 do I have to take to get 4 to the 2x? Well, that's going to be the 2x power. And what power of 4 do I have to take to get 4? Well, that's the first power. So x, when I divide by 2, will be equal to 1/2. Or that's the same thing as thinking of the square root. So 16 to the 1/2, or the square root of 16 is 4. So the 1/2 as an exponent would be the same as taking the square root of something. Now let's look at this one. 8 to the x power is equal to 32. Well, 8 to the first is 8. 8 squared is 64. So what are we going to do? Well, we'll probably have to match some bases. So if I think about this, 4, not a base for 8. I think the only one I can think of is 2. So that's 2 cubed raised to the x power. And then 32, if we think about 2, we go 2, 2 squared is 4, 2 cubed is 8, 2 to the 4th is 16, then we get 32 when we multiply by 2 again. So we get 2 to the 5th for 32. So again, we get 2 to the 3x is equal to 2 to the 5th. So log base 2 of 2 to the 3x is equal to log base 2 of 2 to the 5th. But again, if we think about what power of 2 we need to get 2 to the 3x, we need the 3x power. What power of 2 do we need to get 2 to the 5th? Well, that's going to be the 5th power. So x will be equal to 5/3. Now for this example, we have 27, we're raising it to the x power, and we're getting 3. Now we've already talked about this over there, that 3 raised to the 3rd power is equal to 27. But we're going in the opposite direction. We want a power of 27 that'll give us 3. Well, that means I'm going to need to take the cube root of 27 to get 3. And that's the same as taking the 1/3 power. But if we didn't notice that right away, we could do this same process here. 27 is 3 cubed. 3 is 3 to the 1st. So this is 3 to the 3x is equal to 3 to the 1st. So if I take log base 3 of both sides, I get 3x for this side, and I get 1 on the other side. So x will be 1/3. So we can get that either way. We can either recognize this is a cube root, so it has to be a 1/3 power, or we can go through this process with finding matching bases. Now let's look at this one. So we have 4 to the x is equal to 32. Well, powers of 4, 4 to the 1st is 4, 4 squared is 16, and then 4 to the 3rd is going to be 64. So just like over up here, we skipped over 32. But I know that this is 2 to the 5th. We already figured that out up here. And I know that 4 is 2 squared, so let's put that in. And those two things are equal. So we get 2 to the 2x is equal to 2 to the 5th. I can take log base 2 of both sides. So this side, 2 raised to the 2x power will give me 2 to the 2x, and here 2 to the 5th power will give me 2 to the 5th. So I need 2x for this one, 5 for this one. X will be equal to 5 halves. One more quick thing to note. What if I take log base 3 of 1? Well, I can't start, well, I can start at 3. 3 to the first is 3. 3 squared is 9. That's obviously getting bigger. It's not going to get any closer to 1. And then 3 and 1 don't have any easy way to write them with the same base, since 3 is just 3 to the first, and 1 would be 1 to the first. But remember that if I take anything to the 0 power, I get 1. So log base 3 of 1, I had to use the 0 power to get that. That's equal to 0. Now notice, what if I take log base 29 of 1? Well, I'm thinking, what power of 29 do I need to get 1? Well, that's going to be 0. So whenever this number is 1, unless your base for your logarithm is 1, which it won't be, you're going to get 0. And that's going to hold true for all examples. So notice that some of these problems it was easier to leave as a logarithm. We could just do it straight away like that. Some of them it was easier if we moved them to exponential form. And some of them were just kind of, we could have done it either way.